Welcome to all. As we know that the situation has become very worse due to this pandemic situation, COVID-19. So please take care and stay safe, study well. So today I'm going to explain some of the topic that is included in your last module. So that is module 6. So in this module, what we are going to study is about some of the case studies. What is a possible design solution for the mechatronics approach. At the same time, we are going to study about the design strategies. Design strategy is nothing but how to design with the help of a mechatronic system or with the help of a mechatronics approach. So mechatronics design, you may study all this design parameter or design structure in the first module. You may came across with a design approach or a mechatronics approach, but the same design system or a mechatronic design we are supposed to study very thoroughly in the last module also. So in mechatronics design, so the mechatronic system is a multidisciplinary system that include electrical, mechanical, computer science and the information technology. So this mechatronics design approach that helps to enhance the design very accurately as well as very easily. So as we know that before studying the mechatronic design or before understanding the mechatronic design, you should understand about the traditional design, how the traditional design is working. So once you know about, once you have an idea about what is a traditional design, then it would be very easy to understand about the mechatronic design. So just let me go through the mechatronic design. So mechatronic design methodology is based on the concurrent instead of a sequential approach to discipline design, resulting in product with more synergy. So in this case, mechatronics methodology, it's not a sequential one. So once you have come across or once you have came across with any kind of issues while designing a system, so you can easily recheck the system whether it is working, whether it is correct or not, whether it is working properly or not. All these things you can be done with the help of a mechatronics approach. Say for example, if you are designing an engine, so you should know about what are the engine parameters, right? Say for example, piston of the engine. Piston of the engine is a component or a machine element in which we are facing a lot of issues while designing a piston. So piston is a membrane that should withstand the maximum amount of stresses. Stresses is nothing but the force which is acting per the unit area. So in such a situation, we are supposed to design a piston so in such a way that it should withstand the maximum load. How much load you are applying, that should withstand. So in such cases, we can easily design a piston with the help of a CAD/CAM or a computer-aided software. So that helps to understand whether the design specification as well as design dimensions are working properly. At the same time, we can do analysis in the ANSYS software. So ANSYS software is nothing but just to understand how much stress it can withstand and all. So such things can be easily carried out in this mechatronic design and all. So before that, I am not going in depth into the mechatronic design, but you should know about the traditional design. So then it would be very easy to understand about the mechatronic design. So come to this traditional design approach. So just listen here. So we have a 8 step for designing a system. So step 1 is identify the need or a problem. So this is a very crucial. So if you want to design a system, or if you want to design a product, or if you want to design a service, whatever it may be, you should identify a need. So you should design a system which is needed for the customers or which is needed for the human beings. Then only you will get the pretty good of revenue from that design, or the design should accept by every individual. So in the step 1, what we are going to do is we are supposed to identify the need or a problem. So there should some kind of problems, right? Say for example, just imagine that how to make a Maggie. So for making a Maggie for a person who is staying alone, say for example, that required some amount of water, and we are supposed to put the Maggi noodles. Again, we are supposed to put the Maggi masala, and you are supposed to stir it, right? So we can design a instant Maggi cooker or whatever it may be. So you should understand what is a problem. So what is a problem for making the Maggi is a person should come near to the cooker, may boil the water, put the Maggi noodles, and we are supposed to add the masala and all. So this can be automated, right? So there is a problem. So what is the making of what is a problem we are finding to make a Maggi is nothing but it's a tedious job. Come and boil the water. So at the same, these all the things can be automated, right? So there is we are supposed to identify the problem is nothing but just to make the Maggi. So there are a lot of problems. Say for example, just imagine that when you are talking about the automobiles. Say for example, as we are using the conventional air conditioning system in the passenger cars or whatever it may be. So what is the disadvantage of the passenger car? When you put the AC, so it will continuously cooling. It does not keep a particular temperature. So it will cool up to 18 degree, maybe 16 degree. So the conventional temperature of a person who can sit inside the car is, say for example, 24 degrees. So 24 degrees is one of the ambient temperature with which a person can sit inside the passenger car. So what exactly will happen is, if you automate the system, automated in the sense, if you made a system, if you make a air conditioning system at which you can set the temperature. So that is another type of a design approach. No, I'm just clarifying about what is the point of designing a system. So designing a system or a design approach is nothing but it's not an invention. So invention is entirely different. Invention is entirely different. So what is a requirement? What is a requirement? What is a problem? What is the need of the customer? So accordingly you are supposed to design a system. So that is all about the step 1. So next one is a research the need or a problem. So what is the point of doing the research is nothing but the same problem or same needed thing may have a solution in the past itself. Say for example, somebody already designed a such system, so there is no point of designing or redesigning the system. So you are supposed to do a clear-cut idea about whether the whether the problem is already exploited by some other persons, or whether the problem having or when you find a problem, and those problem which is having already been having the solutions and all that. So you are supposed to do a clear-cut research on the problem what you have taken. So that is all about the step 2. So do a clear-cut study about what you are going to do. So that is on the step 2. So that is all about the research, the need or a problem. So when you are coming to the step 3, so next is a very important, that is a develop a possible solution. So develop a possible solution is nothing but you are supposed to find a you already find a problem, and you have thoroughly studied the problem or a need, what exactly it's required and all. So third step is nothing but develop a possible solution. Possible solution in the sense, for your problem, if you are a 4 members group, each person having a different methods to solve a problem. So you are supposed to highlight the possible solutions. Say for example, you have a problem. So if you want to clear that problem, there are imagine that if you're in your group there are 4 persons. So 4 people or 4 person having a different set of ideas. So you are supposed to come up, or you are supposed to develop the possible solutions. So that helps to recover or that helps to develop the solutions. So in such a way that you can select the best solutions. So that is happening in the step 4. From the possible solution, you are going to select the best solution. So that is very important while doing the traditional design approach. So next one is construct a prototype. So before before going for the manufacturing system, or before going to a manufacturing kind of structure, you are supposed to construct a prototype. Prototype is nothing but a single unit, a single piece of unit of your product. So that is it's a miniature model, or it's a prototype. It's a single unit product which you are going to manufacture for a particular problem. So after that, sixth step is nothing but the test and evaluation the solution. So whether you have made you already made a prototype, you are supposed to test and evaluate. Maybe you are supposed to go for a non-destructive testing. If it is a mechanical component, you should go for a non-destructive testing. And you should make sure that your product will withstand all the parameters, all the stress, strain, other factors, temperatures, kind of stuff. All the things you are supposed to consider, or you are supposed to test and evaluate the prototype which you already made in this situation. So next one is communicate the solution. So you are supposed to, if the test is successful, then you can directly jump into the production to make n number of product, and you can float it into the market. And if you find out any kind of problems in the testing part, you are supposed to communicate with the people who made the solutions, and you are supposed to redesign and do the cycle. So this is how a traditional design approach is working. So what is the problem of this traditional design is, what is the disadvantages of the traditional design is, you can identify the need. That is a pretty good, as everyone is doing for the traditional design as well as mechatronics design. Then next one is a research the need or a problem. So as we know that, develop the solution. We are taking the best possible solution, and we are making a prototype, and again we are doing a testing. During the testing, we are not able to understand what is the problem of our design. After the test report coming out from the testing center, we came to know about the things. We came to know about the system is not up to the mark or up to the standard. So again you are supposed to do a redesigning after the prototyping. So this would be little bit a tedious task, because once you made a prototype, that is entire loss in the capital, entire loss in the money. So in such a situation, this would be not pretty much applicable for the design approach. So next one is a mechatronic design process, or a mechatronic design approach. So it's a very interesting is we can convert, or we can make 3 different areas of a mechatronic design. First one is a modeling and simulation. So next one is a prototyping, and another one is a development or a life cycle. So mechatronic design approach. So I will give a abstract, or I will give a introduction about what exactly the overview. I will give a overview, not abstract or introduction. Overview is, it's a very simple. So what you see here, it's a traditional design, right? So all these steps have to be done with the help of some kind of information technology, or with the help of some software. So it would be very easy to do the entire design process. So just imagine that designing a automobile engine would take almost maybe 2 or 3 years to design an automobile engine. But with the help of a mechatronics approach, we can design an engine which is having a span of within 6 months and all. So in such a situation, mechatronics approach is one of the best way of doing the designing. So here also, in the modeling and simulation is nothing but you are just collecting the basic conceptual design function as well as design functional specification. What we are doing is modeling and simulation is nothing but just calculating if it is having any kind of mathematical modeling. We are just calculating with the help of this mathematics. It's a simple kind of basic kind of physics which we are applying in the modeling and simulation. Just imagine that we are just modeling what is our recognition of need. After that we are just understanding what type of sensors which you are using. So while selecting the sensor, you are supposed to go think about the characteristics. What all the characteristics which is required for our situation, for our design process. So next one is a control system. Design of a control system is very important. So what type of a control system is required, whether it is open loop control system or a closed loop control system, and you are supposed to understand about whether the process is a continuous process or a discrete process. So such kind of things we are supposed to we are supposed to clearly mention in the modeling or a simulation stuff. So it's a very important one. So it's a basic part. So that include the basic physics, mathematical modeling. At the same time, you are supposed to select what all the things you are supposed to be considered. Say for example, what type of conceptual design you have. At the same time, what type of sensors and actuators you are selecting. So next one is a control system. What type of control system we are using. All these things comes under the modeling and the simulation stuff. So that's all about the modeling and simulation. So next one is a prototyping. So before doing this prototyping, we came across with a topic called design optimization. Just look at here. So this is what is called the design optimization. So as I told that we in mechatronic design also, first step is nothing but the recognition of the need, or you are supposed to find a problem, right? So according to that problem, we are going to design a particular product or a service. So in such a situation, you are supposed to recognition of the need or a problem. So next one is a conceptual design and the function specification. Conceptual design means if you have any kind of design or if you have any kind of concept in design, so you can adopt that. So next one is a first principle modular mathematical modeling. Then select the sensors if you have any sensors and actuators. So while selecting the sensors, just go through with the characteristics of the sensor, whether the sensors which is capable to sense our working environment or output of the system. So that is very important. So that is all about the sensors and actuators selection. So next one is a detailed modular mathematical modeling. So that is also important in the sensors also. So next one is a control system and control system design. So when you design a control system, that should be whether it is open loop or a closed loop, whatever it may be. So next one is a design optimization. Before going into the prototyping, you should go about the design optimization. So design optimization is nothing but you are supposed to recheck the system. You are supposed to recheck the system if there is anything, say for example, all the things which can be simulate nowadays. Say for example, if you are designing a circuit, so we can check the output, whether you are getting the output very accurately or not. Whether you are getting the output accurately or not. So if you are getting output very accurately, then it's fine. You can, after design optimization, you can directly go into the prototype. And if after selecting the sensors, after selecting the control system, and you are doing the simulation, and if you are unable to make a output very correctly with the help of any kind of softwares, and you are supposed to recheck the system. You are supposed to recheck the system. So that is mentioning here with the help of this arrow mark. So there is a kind of arrow mark which is mentioning in the first principle modular mathematical modeling. So we already discussed such things. So you are supposed to recheck whether the system is working correct or not. Again, you are supposed to do the designing and all. So that is all about the design optimization, and you are supposed to be very clear about your design. Then you can make the prototype. So in mechatronics approach, the main advantage is after going or after going to do the prototype or while doing the prototype, before you can check whether the design is a successful or not. So that is a main advantage of the prototype. So this will enhance or this will reduce the amount of designing cost. So it's a very important for the manufacturing aspects. So once the hardware in loop simulation is nothing but you are making the system and you are working with the help of a hardware, and if you able to make the prototype, or if you able to make the prototype very accurately, you can, and you are getting a pretty good of output, then it's okay, fine, and you can go for the design optimization, and then it go for the deployment or a life cycle. So this is how the system is working. This is how the system is working in order to in order to make the product. So in such a situation, we are using this type of a mechatronic system. So it's a very convenient for the mechanical machine design, at the same time any kind of electrical design. So as we know that nowadays all the mechanical component which is working with the help of electronic items or electronic sensors. So in such a situation, we are supposed to use this type of a mechatronic design approach. So thank you guys. So this is all about the mechatronic design. So I'm going to conclude my session of this topic. So keep watching the YouTube. So I am going to upload n number of videos for your study purpose. Just go through the videos and study well.